So once more, we have something I want to discuss, and this is just to clarify what we're talking about when we talk about joins. Joins are basically based off of various concepts on set theory. All right, so we can use set theory once again, just like we had been using it all along. We use select, we use um, things such as union, intersection, union, all that type of thing. But in this case, we have a different type of way of working with our set theory. Joins allow us to truly try to combine different outcomes together without having to have the, you might say, narrow restriction of being union compatible. So let's go through this. The simplest syntax for using a join would be as follows. First, I'm going to talk about how to do the Cartesian product, where basically you have a cross product. Well, I don't want to call it a cross product, but we have a Cartesian product which matches every element from A with every element from B without any particular, you might say, structure to the sets that are resultant from it. All right, so you're going to find the syntax for H2 under the select part. If you take a look all the way down here with our select expressions, all right, the join is going to be within the following. Here we have a select expression, and then we have the from table expression, all right. This is the area by which we find those things. Now, in the event that we have a lot of redundant data, we may need to use the distinct keyword. That way we can pull things out one at a time. And if they are, how can I say it, repetitive, if they're understood to be exactly repetitive, then distinct will drop all of the columns that are duplicates. So now in our select expression, we have things such as being able to use a wildcard, which you guys have seen already. We also have the ability to use things such as and or, and then we can also create column aliases. So this would be like saying select from table, and then I say name, but I'm going to use the word as. All right, so the name is as something else. As you can see here, they use ID as value. All right, so that's normally done with columns. Now, if I want to do something similar with tables, it would simply go as follows. After the table name, right, I would just simply use the alias name following the table name itself. So if I say select from math majors M, all right, then I can then use m.name as, math majors.name. So the standing goes just like that. Now, scrolling up, remember that we also have a table expression. This is where it gets interesting. So here's my table name, all right? But now take a look. Once I come down through all of this other stuff, here's the table alias that I told you would be possible, all right? But now I need to come all the way down, and when I get here, this is where things get interesting, all right? Here I have something called left and right. Then I have also the optional outer keyword. I also have an inner keyword. I have a cross keyword and a natural keyword. All right. So let's talk about all these different joins. I have a left or right join, but they can also be outer joins as well. Here's the join table expression. Let me just see if the link is broken. It should not be. Oh, okay, well, that's not broken. And so with the join specification, I should tell you this one thing. Because we are not bound by using data sets that are union compatible, what we're going to have to do is have the entire join centered around a given common denominator between both of our tables. Now, the common denominator does not necessarily have to mean that that particular item in question has to have the same exact name. However, what it should have is the same exact data type or data representation. So if you see this part right here that says on BID equals a dot parent ID, there we're saying that collectively the comparison between these two parts of the corresponding tables will be the backbone of how the join is used, or the backbone around how the join is executed, I should say. So, moving back one, let's go down the line. First, I'm going to use a cross join. All right, it's going to go as follows. So suppose that I have math majors and sci majors. All right, so select star from. Now with the cross join, we don't have to have any sort of pivotal column or parameter. We could just use the cross join because it's understood that we're just taking the Cartesian product between two different sets. All right, so I'm going to use math majors. And this is going to be cross join. Sci majors. So this thing right here is going to be the equivalent of the following grammar. Looking at our select statement, we have the following. Select. Now we're moving all the way over here to the select expression. All right. And then finally, we're going to go to this table expression. All right. So now, the table expression part, this is where we were. And I'm simply saying that we want to now use the cross join. As you can see, there's no need for me to have a join specification for the cross join. All right. Now for other joins, having the specification would be vital. It helps you to see what it is that you're comparing across two different data sets. So cross join in this case is my operation, and I'm just going to use run selected. Now that's my outcome. All right. So now if I look at the entirety of what I have here, we're going to see that it's a very large number of items. All right. So I have 121 rows. That's because I took both. I took both tables, and I simply took every row in those tables, and I made a new subset given the combination of those rows. So these joins are actually at many times going to produce very, very large result sets. Okay, so that's how my cross join works. Next thing I'm going to do, I'm going to want to use a natural join. Let's just take a look at how it works. So the natural join, a lot of times, if we don't specify anything, that'll be the join that they believe to be the actual standard, I guess you could say. All right. So the natural join, let me just show you what it looks like. And I'm just going to use these two guys right there. All right. Now I'm going to change this to a natural join. Okay. All right, that's my natural join. All right. Now, these are the very, very basic joins that are done. You might be wondering, what does a natural join do? Natural join does the following. Okay, so here we're going to have a join clause. And what it does is it can be an inner join or one of the outer joins like left or right, right? However, by convention, it's usually going to be an intersection type of join, so that's an inner join. All right, let's take a look at how Oracle explains this. So here you have your table expressions. We've already done that. Okay, but now moving back one, we have natural. We also have join. Now, if you take a look at these square brackets, all of these things are optional. All right, but in the case that we use a natural join, then we can, after that, use this next part that is in curly braces where it may or may not be necessary. So this is the table or view function. All right, we have a table name or view name or the subquery of both of them, one or the other. We can also have the following. We can have another table expression. Okay, so now, by default, in this particular case, we're using an inner join. The inner join is just going to give us intersections between the two of them. All right, so it's going to tell us which parts we have in common. Now, in the event that there's nothing that we have in common, we're going to get an empty set like what we got there. But had this really been math majors, we're going to get everything that was in math majors because of the intersection. Let me just double check. Okay, here's how I'm going to do this. Let's say math majors A. This is math majors B. All right, so in this case, the table alias was absolutely necessary. And basically, they're going to treat this as A, that's treated as B. Without those table aliases, they would have thought that we are trying to use the exact same thing. However, you can have something called a self-join. And I should make it clear that not every database management system is going to implement the exact same thing. So you may find that there are other systems that have more joins or fewer joins. All right, you have to actually check with the database management system. Joins and merges are not always equally featured the same way. Okay, so now, next thing I want to do is as follows. I'm going to move into the other joins, and then we'll see what we have that is either left or right or full. Okay. Given my other grammars, I have the following. I have left and right, but I also have left and right outer join. All right. Here I have an inner join, and here I have a cross and a natural join. All right. Now for the join specification, we don't use it for cross and natural joins. A natural join is basically going to be the inner one. All right. And the condition is automatically on the columns with the same name. So here are some examples. But what we're going to do then is start to disambiguate how there is a difference between the natural and cross joins versus the remainder of our other joins. All right. So left and right inner. We've already seen what the inner join looks like. Let me just show you. This is going to be an inner join. All right, and that gives us our intersection. If you remember what we did with